Okay, number one, we're going to solve this by substitution. In order to solve this by substitution, what you're going to do is you're going to take one equation and substitute it into the other equation. Now, since this equation, y equals x minus 1, I can replace, in the previous equation, I can replace all y values with x minus 1. So I'm going to take this first equation, and everywhere I see a y, I'm going to stick x minus 1. So I'm going to stick x minus 1 right there for y. So this is going to be an x minus 1. Now, why do I do that? Well, I can solve that now. I can solve this for x, because it's one equation with only one variable.
You gotta multiply that, though.
In order to solve this, you're going to multiply the negative 2 times the x, giving you negative 2x. Oh, don't forget the x in front. The x stays in front. So negative 2 times x is negative 2x. Negative 2 times negative 1 is positive 2. And then that 2 comes down. In order to solve this, well, combine these x's, you get negative 1x. And then to keep solving this, we want to minus the 2 over. So you get negative 1x equals 0. Divide by negative 1. And we got x equals, what's 0 divided by negative 1?
0.
It's actually 0. So x is 0. We're looking for a coordinate, x, y. Remember, that's x, that's y. Now, once I know x is 0, we want to plug it in. Now, of your original equations, which of these two original equations is easier to plug it into? Hopefully you notice the second one is really simple. Because I could just take that x minus 1, and can I put the 0 in for x? Can I put this 0 right here for x? So you get y, what's 0 minus 1? Negative 1. So, right there, 0, negative 1 is where these two graphs would cross. It's called substitution. You take one equation, plug it in the other, and then you solve it. You take your answer, plug it back in. That coordinate is where the two graphs cross. Now, number 2. By the way, this ordered pair, this is an ordered pair. A pair of numbers in order, x, y. Here I want the ordered pair for the solution using elimination, also called linear combinations. And what this process goes is you add straight down and try to cancel. Now, but when I add straight down, do they cancel the x's or the y's? No. So what I'm going to have to do is I'm going to multiply these equations by something so that we can cancel them. So either you cancel the y's or you cancel the x's. I'm going to cancel the y's. And the way you do it is, what can I change negative 2 and 3 into so they can be the same number? Do 2 and 3 both go into 6? So what do I need to multiply negative 2 by to make it a 6? 3. What do you need to multiply 3 by to make it a 6? 2. Now, could I have also made a 5 here and a 3 here to cancel the x's? Yes. But I chose these numbers. So I chose 3. And what I do when I multiply 3 times x, I end up with 9x. 3 times negative 2y is negative 6y, and 3 times 2 is 6. 2 times negative 5x is negative 10x. 2 times 3x is, 2 times 3y is 6y. And 2 times negative 2 is, 2 times negative 1 is negative 2. So what I did is I multiplied this 2 by everything and this 3 by everything. And where I got this 3 and 2 was I looked at the y values and I thought, okay, what number can I create so that they will cancel? And I thought of 6. So what you'll notice is if you add straight down, these cancel now. If you add straight down, doesn't that become negative 1x? And if you add straight down, doesn't that equal 4? And to solve that, can't you divide by negative 1? And you got x equals negative 4. Now what's the point of that? Well, negative 4 goes right here. How do you find y? Which of these two do you want to plug it in? It really doesn't matter which one. I'm going to take the top one. 3x minus 2y equals 2. I'm going to take this, plug it right there. There's my 4. 3 times 4 is 12. Bring down the 2y. Bring down the 2. Can you solve this? Yes. You minus the 12 over. Negative 2y equals negative 10. Divide by negative 2. Now, this one right here, what should this be?
It's supposed to be 14.
Oh, it should be a negative 4? That's a negative 4. Should it be negative 4? Should it be negative 12? So this should be a positive 12. Thank you. So this should be a positive 14. Does that look better? 14 divided by negative 2. This cancels here. Positive 14 divided by negative 2 is negative 7. So that would be negative 7. Thank you for correcting me. That would be a negative 12 again, because negative 4 times 3 is negative 12. Add it over. Divide by negative 2. That's the coordinate where they cross. I like linear combinations. I also like substitution, but these are all dependent on what type of problem is thrown at you. It depends on what they're given to which method you need to use.